What's up, hackers, and welcome back to IT at the Forge. We're continuing our dive into the finer details of networks this week as we talk about protocols. As with a lot of things, you've probably been exposed to and practiced protocols your whole life without even realizing it. A protocol is nothing more than a structured and formal way of doing something. For example, the communication protocol for introducing yourself to someone new goes something like this. Hello, my name is John.
Hi John, my name is Ashley.
Very simple. In a live classroom setting, it is typically protocol to raise your hand and wait to be called on to speak. Basically, protocols are rules. And in the context we're exploring, they are the rules that allow effective communication between computers on a network. Now, you cannot talk about protocols in the world of networking without mentioning something called the OSI 7-layer model. OSI stands for Open Systems Interconnection, and its 7 layers are physical, data link, network, transport, session, presentation, and application. Let's say you're a furniture designer and you've just designed a bed that you want to ship to a relative that lives a few states away. Now, there's certainly a process to getting this done. You can't simply put the fully assembled bed at your front door and expect it to go anywhere. You must first break down the bed into as many individual parts as necessary. The sheets, blankets, and pillows are taken off. The mattress and box spring are set aside. The frame is broken down into smaller parts. All the necessary hardware like screws and bolts are kept together and set aside. But now you have to package all these things up individually and make sure you label them to go to the same place. You can't very well fit a mattress in the typical outgoing mailbox, so you're going to need to find a proper shipping company that can handle the large item for you. So you make the necessary arrangements for the company to pick up all of the pieces. That company then looks at where it's all going and prints some labels of its own that indicate what route it will take within its own network of shipping and distribution centers. All the pieces make their way on planes, trains, and trucks to the distribution center nearest to your relative's home, where it eventually makes the last leg of its journey and is delivered. But wait, not done yet. Still in boxes. Can't really make use of a bed in boxes. Your relative then proceeds to open up each individual package and assemble them all together into a fully functional bed. Now, in this scenario, the process of designing the bed in the first place is best represented by layers 7, 6, and 5, or the application, presentation, and session layers, respectively. A good way to think of these layers is the actual creation of the data and any relevant steps to that process. Encrypt it, format it properly, compress or decompress it, and send or present it to the user. The next step is preparing the bed to ship, breaking down the data into manageable segments and finding appropriate ways to transport it. Now, we're going to spend a few minutes looking at this a little more closely, as there are 2 very big and important protocols at this step: TCP and UDP. TCP stands for Transmission Control Protocol. This protocol is used for what is called reliable data transport. It first establishes a connection with the receiving machine with what is called the TCP three-way handshake. Now, this is essentially how it goes down between computers. Yo, I want to talk with you. You want to talk with me? That's cool. I'll talk with you. Red, let's talk. Now, once this connection is made, the communication is reliable in the sense that the 2 machines know what to expect from each other so that the data is sent and received correctly. Now, UDP stands for User Datagram Protocol. This works a lot like TCP, but with one key difference. No connection is ever established between the 2 machines beforehand. Data is just sent. Now, this would be like not telling your relative that you're sending them a huge bed and giving them no idea of what to expect in terms of parts or instructions or how to put it together. Whereas TCP is like calling up your relative beforehand and giving them a detailed description of what you're sending and maybe some instructions on how to put it together. You might tell them that you're sending it via a particular shipping company and how many boxes to expect. This way, if anything is out of place or from some other shipping company, they will know about it and can respond accordingly. You would also make arrangements for the shipping company to come pick up the items at your front porch. On a computer, there are specific ports that applications can send and receive information on. Port, porch, port, porch. Get the analogy? Now at this point, you've let your relative know what's going on, you've broken down your bed into parts, and you put your packages on your porch for the shipping company to pick up. Now it's time for the shipping company to do its thing. Now first, it's going to print out a label that will provide an address to its destination point and slap it on each of the packages. This is a lot like data being put into an IP packet, with an IP address for its source and destination. Now packages in the real world, shipped long distance, often make several stops along the way to their destination in a series of shipping centers. At each shipping center, the packages are received, get a new label, and put on a new truck to their next stop. Similarly, packets will make several stops along their way to their destination computer through a series of routers. At each router, the packet is received, then put in a frame that contains information for its next router stop. That truck then travels on roads to get to its next destination. The road is the physical means by which the packages are transported, just like Ethernet cable or Wi-Fi radio signals are the physical means by which data travels. And once the packages reach the shipping center closest to your relative, they are marked for delivery and brought to your relative's home, where they are opened and assembled again into a bed. In network terms, when the packet reaches the router closest to its destination computer, it is delivered to the appropriate port, porch, where it is then opened and reassembled. And that is how a simple little message travels over the internet. It's important to realize how data moves both up and down the stack as it moves through a network. When a message is sent from your computer, it moves down the stack. When it's received by its destination, it moves back up the stack. Now we've gone over a number of protocols that exist in this model, but before we identify a few of those, we can simplify the OSI model a bit by looking at the TCP/IP suite of protocols. For these, we can bundle together layers 5, 6, and 7 into one layer called the application layer. Layer 4 remains the same, the transport layer. Layer 3 also remains the same, the network layer. But layers 2 and 1, however, can be bundled together as the physical layer. Now let's look at some of the protocols that exist in these different layers. Starting at the application layer, we've learned about HTTP, or Hypertext Transfer Protocol, which is used to fetch resources like HTML and web pages. There's also DNS at this layer, or Domain Name System, which keeps track of domain names like youtube.com and matches them to IP addresses. We just learned about TCP and UDP at the transport layer, which have to do with establishing or not establishing a reliable connection before transmitting data. IPv4 is a protocol that is part of the network layer. This is how the packets know where to go on a network, as IP addresses apply to source machines and destination machines, and all of the routers in between. Lastly is the physical layer, which contains standards and protocols like Ethernet, 802.11 or Wi-Fi, and the MAC addresses, which is the burned-in physical address of a device. There are several more protocols involved with this process that can take quite a while to get a firm understanding of. But if these things interest you, then rad, by all means, explore more. The internet is full of resources for learning more about networks and how to take advantage of them, which is what we'll talk about next time when we go over cybersecurity. See you in the Forge.